Hi and welcome. So I've got a new project this week. It's from an aerospace company I do work for occasionally. And basically it's taking large pieces of tubing, at least some of it, and making it into a very precise length or relatively precise length, small pieces of tubing. It's all stainless. So the two different sizes, this size and this size, need to be cut up into specific length piece of tubing, plus or minus 5/1000ths. This size tubing, which I'm going to be very curious to see how well this works, I've got to ream the inside, and I've got to reduce the outside by a few thousandths, and then I've got to cross drill a number 64 drill bit into it. So that's going to be interesting. This is my gauge to see if I've got the inside diameter correct, the shank of this, and they supplied a reamer and some drill bits. So a lot of this won't be super exciting, but I'm going to show some of this, how I'm getting the relatively precise sizes. So for starters, I'm using this fixture I made. There was a hole drilled and tapped in the side of my quick change tool post. So I built this adapter a la Joe Piezinski. And what you do is, kind of made me wish that I had a collet closer. In order to set, I bring my cross slide back, so to set the depth, I pull this until it contacts the cross slide, and then I've marked on my chuck, I think that's in frame, right? No, it's not, of course not. There, maybe you can see there. I've marked on the chuck body and the chuck wheel here a green mark so I can line it up every time, because as you tighten the 5C collet, it pulls tighter into the chuck, which pulls the part back. So it's not straightforward. If you have a collet closer, it's going to pull the same depth every single time. So once you preset it, it's pretty good. If I don't line these marks up every time, it ends up being off by more than a couple thousandths. So that's kind of surprising. So you bring it out, tighten it. But now the advantage is now that this has pulled the 5C collet in a little bit, it won't rub. So I bring this piece back and I just cut it off right here. So the first step here is you just pop this guy in, and this is 3/16 stainless, so it's pretty sturdy stuff, and it's gummy all at the same time. And I just take that part, toss it in there, then I got to stop the lathe, then I use the brake. I bring the cross slide back so that this lines up with the part. Step on the brake, loosen the wheel a half turn. Bring this out until it contacts, step on the brake, tighten until the two lines are lined up. Bring this back and go again. So it's leaving a burr on each one of these, which I will have to deal with next because he wants both inside and outside deburred. So to remove the burr that's left over, I just grab a piece of side cutters and you just basically squeeze it and it peels off the stainless. It still leaves a little bit of a burr on the inside, which I need to deburr. And for that, I use the Tom Lipton solution currently, but these actually are kind of hard to do by hand because you have to hold these really tight. I've just got this inexpensive little Harbor Freight motor with the McMaster car. It's like $40-some for this countersink, and I was holding these and deburring them, but instead I'm gonna put a fixture on the mill and just do these all together and come back and do them because it's kind of a pain to do it by hand. But anyways, just repeat that. So that's what I'm doing for these parts. I'll bring you back when I do the one where I have to reduce outside diameter, ream the inside, and then cross drill. So as I'm doing these, they're getting so freaking hot that I've decided to put a couple cloth band-aids on my fingers so I can grab the part, because I was actually getting burns, and my fingers are pretty insensitive to heat, but these guys are getting hot. And you may be saying, well, why can't you use coolant? Well, for the application, I don't think they can afford to have any coolant residue, so I'd have to find some sort of solvent tank, which I don't have, to make sure to get all the residue off. So instead, I'm cutting them all dry. I was having a problem with parts coming up short, so I needed to draw this rod back, but I wanted to do it in a controlled way, so I put an indicator on the end and then slowly inched it back. It might be interesting to have some sort of threaded adjust on this to have better control, because it was kind of kludgy doing it by hand, just fighting the friction. But I got it. Now that I got them down to size, I got to get off the big burr before I can remove this. And what I'm doing is I'm just using a pair of dikes here, similar to the way you could use a nice vise that's got sharp jaws to do the same thing. This is 316 stainless, so it's pretty tough stuff. So I'm doing this. And next up, I'm going to take the outside burrs off, and this being stainless is very gummy, so it turns burrs everywhere. So then I'm going to take it over the Scotch-Brite wheel and do the outside of both these guys. Then I'm going to come back and I'm going to do the inside. Working on the Scotch-Brite side. Got lots of light above. That's the Harbor Freight 4-bulb light, and it puts out just a ton of light. And I won't be able to do this one-handed, but I was starting to do this way, and you can see the grooves in the Scotch-Brite wheel, maybe. So I started doing it like this instead. And actually, if you catch the light right, I don't know if you can see it, but there's like a little glow where that burr stands out. Yeah, you can sort of see it on camera there. So I'm holding them fairly vertical, and it's just taking that burr right off. Next up, we need to deburr the inside and of both sides. So I was gonna take a fixture over here and do it, but it doesn't look like it's really necessary. Using the Lipton solution instead, and just gotta do a boatload of them. So here's my my next approach, because you can see it didn't take very many before my hands got tired. Because deburring all these others in the grinding wheel, I was rotating this by supporting with my bottom finger and then twisting with the top. My hands got pretty tired, so by the time I got here, grabbing with the pliers each one, even though it's quick, was getting really tiring. And so this guy, we'll make short work of it. Pop the 5C collet out of the lathe, and we're just whipping through these. We've got, I don't know, 100 and something of them to do, so it's pretty time consuming. Hopefully I won't drop everyone, but I'm glad I didn't attach this to the bench, because I considered doing that going in. That would have been more problematic. That's it. One thing I thought about for deburring the outside was tumbling them, and that probably would work. My problem is I don't have enough experience with tumbling to know what would be right, what would be wrong. Also didn't know, would have to talk to the vendor, because these are an aerospace application, and maybe they can't afford to have grit anywhere near them. That's part of the deal. Like the stainless that these are made out of had to be traceable, quality traceable. So everything with aerospace tends to be a whole other level of particular, for obvious reasons. The potential downside is huge if you screw up, so better be safe than sorry everywhere. So I've switched to the Bosch. It's higher RPMs, speed up the process. And when you're doing the number I'm doing, shaving a few seconds off each part ends up adding up in the end. So anything in the name of efficiency here. I think I find that I don't typically enjoy massively repetitive jobs a whole lot. I sort of like problem solving. So if I can't think of a way to make it faster, there's really no problem solving, and my brain kind of goes numb. One thing I find that as I do more and more of these, the debris gets around the outside of the 5C collet, and it starts getting tighter and tighter because it's wedging the debris against the outside of the collet. So that's sort of a negative. It kind of could use a little shroud that goes over the edge of the collet here. That might be nice. If I had to set this up as a factory setting and I wasn't just doing 100 and something of these, I think I would definitely consider that, because it's kind of annoying. I brushed it off, but yeah, see, it's still sticking. You can see some of the debris getting in there. So just an observation. You're wondering how much material we actually removed. Surprising amount. All right, so finally, there's a few more of these too, because he had pre-cut some and he gave them to me, and he wanted them cut to length. They're actually a little bit long. He's got this really cool abrasive chop saw that he said can hold 5,000ths accuracy. It's kind of neat. But so to cut these to size, I set my 5C collet with a collet stop inside. I don't know if you can see it, probably not. It's down 600 thousandths, and then I set the edge of my cutter right at the edge of this, and then came out another approximate 150 thousandths. Actually worked out to 138 with a little bit of trial and error. And then you just stick the part in there. I've got the carriage locked off. I tighten it to the exact same spot every time. So I've got the mark on the wheel, hand wheel, and this guy. And go at it and get them all to size. And we'll give them a few more. So with these guys, I've had a bit of problem with this next size up, because this tubing is, I don't know if you can see that. You see the little seam in there? This is folded and welded tubing. You can sort of see the line on the outside too, but it's really noticeable on the inside. So as opposed to die-on mandrel tubing like the last stuff I used, where it's extruded, this is folded. It's sheet stock that's folded and welded. And as a result, this stuff's actually 0.450 instead of 0.4375. And as a result, it's making the collets really tight, and it slides really tight. So the problem I'm having is you have to be really consistent about your operation. So when you open it up, if you open it up really far and you just let go of the stock after it's held by the, held against the stop, and I just pull it in, it'll suck in much more, because it's sucking in continuously. It never just floats. So what I have to do is I have to hold it against the stop until the last inch or so, then let go of the material, and it'll create a small gap in there, and I can repeat that over and over. The other thing I could do is open it up, have another mark on my collet, which is the open mark. Always open it to that open mark. Pull the material out to the stop, let go, pull it back to the stop, and it would be repeatable. Or I could use a feeler gauge in here potentially, but it's very problematic. Another thing I just started doing is to get this little burr off. It's a pain in the butt. It gets quite hot. And what I've done is, you can see the color change there, is I've been quenching it in alcohol. Hopefully that'll make it easier for me to remove when I get to the end. It may not actually. It might make it it might make it so hard that it damages the deburring tool I use. I guess we'll have to find out about that one. So I learned another little trick here. So the little extra material sticking off here is a pain to get off. And what I was doing is taking these diagonal cutters that are hard. They're designed for hardened steel. They're Lindstroms, if you're wondering what type. And then mostly just peeling off the part. But it actually takes a bit of effort. And I've discovered another trick, now that I've got all these set to go to size, that makes this much quicker. All right, so here we are again. I've got the little burr sticking out there. Pop these guys in. Tighten them up. And just let my parting tool push that piece off, because it was challenging with the diagonal cutters. That's the next bunch done. Now we've got the complicated ones. Well, the material of this tubing is kind of variable in size, enough so that I'm having to do this by feel rather than by mark on the collet chuck here. So I'll show you what I mean. So I loosen it up, and I spin this guy back, and I pull the material out, which is very stiff because the outside's got a lot of oxide on it. And then I run it up till it's just barely snug. Then we got to take like a 1,000th off the outside diameter. So I've been resorting to a lathe file, which has actually been working really well. I was using sandpaper, but that wasn't great. I've had to resharpen this parting tool a bunch of times. It gets dull pretty quickly. It's an inexpensive Chinese insert. And all I do is take it over to my diamond wheel and just put a positive rake into it, which also makes it weaker, but tends to cut the stainless better. Eventually it starts smearing the stainless. I also have had to add lube, which means I have to clean all the parts after. So I cool it off by tossing it straight into an alcohol bath, and then I measure each one, because with this method I'm tightening the collet by feel. If you over tighten it, like match the line, then you suck in the part more than you should, and vice versa. So it really is by feel. All right, if you're wondering what it sounds like, the difference between The regular, the dull cutting tool, and here's just a fresh one I just put in. You probably heard the others. See, it's rolling up the chips. Problem is this 316 stainless, they don't stay sharp for long. Night and day difference between the cutting sound on these guys. So I'm supposed to be reaming out the center of these 0.4375, but they are 0.4250, which means 125 thousandths has to come off. That is way too much material for a reamer. So I've got a 0.4375 end mill, and I'm going to try and ream them with the end mill instead. And we're going to give that a shot, because I did it with the reamer and it works, but reamers were never designed to do that. So we're gonna try with the end mill and see how that works out for us. So we're gonna use the end mill, and we're gonna do it with lube, because this is still 125 thousandths. This is really thin wall, so I'm not sure how it's gonna act. I'm gonna go in slowly. He gave me this tester here, and that's a really nice fit. Next up, we're about to try something I've never attempted before, which is using drill bits below number 60. And these are number 64. And I didn't look them up, but I was told they were 30 thousandths. And he gave me more than one, because you know the possibility of breaking something like this. Yeah, you can see how tiny that is. So I've got my sensitive drill thing here that I've never used before, but we are going to give it a shot. This is stainless we're drilling into, which is nasty gummy. So I'm going to turn up the speed up to like 4,000 RPM, and we're going to see if we can pull this off. I'm not sure I can. Alright, so rather than use these really long number 64 drill bits, I'm pre-drilling. I actually had a metric drill that was 1/2 thousandth undersized, but I jabbed it into my finger and broke it off into my finger. It cut through this like butter. This is a 0.7. I needed a 0.9. I don't have any 0.9. So I'm using a 0.7, and I'm going to follow it up with a drill, but it's going to take twice as long, but maybe we can get this done. Because these carbide bits drill about 100 times faster. These are PCB drills. And they drill like 100 times faster than these guys do. But I got to change drill bits each time. It's going to take frickin' forever like this. I've got like 100 of these to do. So that one goes out. Then I got to close the drill bit up, the drill chuck up, and then try and get this to line up in the center, which means you got to make it smaller first. Here we go. And turn it on. Well, that's a hell of a lot easier, because doing it with these high-speed steel ones was worth your life. So that's what I'm going to do. I'll be here a long time. I'll bring you back later. Finally done. To complete this many, got many drill bit casualties. Most of them were right in the beginning when I was trying to figure it out. All right, here's everything. So I'm about done, unless I get the drawing in a timely fashion, which I don't think is going to happen. So that's probably it for this video. It was very tedious, but I learned a lot because trying to mass produce parts accurately is very difficult. And so there was a lot to be learned here. I messed up a bunch and had to get some more material for the smaller ones, these guys. But all in all, it was a great learning experience, and I don't regret it. Anyways, thanks for watching. Hope you find it interesting. Hope to see you next time.